Hey students, welcome back. This is part 2 of chemical reactions. We're going to transition to just a small amount of stoichiometry. Today's video is 5.5, but first we must start a review of 5.4. If you came to our check-in the other day, you have already done this review, and so you should have it. If not, hit pause, go ahead and balance and classify each of those reactions and meet me down below. Okay, here we go. 5.5 is where we shift gears a little bit, and we're going to talk about stoichiometry. All right? Stoichiometry is basically helping us figure out apples to apples, if you will. We won't get to the apples to apples today, but we will start the process. So here we go. So we're going to start with just a simple method today. We're just going to do the multimole, which is just the third step here, but I want us to write down all the steps because it's going to be good practice for us, and we always have to do the first step. So today we're going to be doing the first and third step, and in the next video, we'll be doing all 4 steps together. So here we go. First step is we're going to blow this up just a little bit. We're going to write a balanced equation. So our first step is that we have to write a balanced equation, which is why what we did kind of before spring break is so important, because we have to be able to write a balanced chemical equation for us to be successful on this, because if we don't have a balanced equation, we cannot do our next step or the next couple of steps. So step 2 is going to be to find moles, and that's going to be by dividing by the molar mass. All right, so we found molar mass, so we're kind of just putting all of this together that we've done in the last 2 or 3 units, moles to now. All right, find moles by dividing by the molar mass. Our third step, which is the step we're going to do today, is we're going to do the mole-to-mole ratio, what is called the mole-to-mole ratio. And this is where we put where we're going, or what we're looking for, over where we've been. And this is from our balanced chemical equation. And you maybe heard, like when we were doing our balancing, that I referred to those coefficients out front as moles. Well, that's what we're going to be using, and we'll see that in just a little bit here. And letter D then is we're going to find grams. And to find grams, if we're at moles, is we will multiply by molar mass. So again, that's these 2 steps we're not doing today, but it's good to have them written down, because the next video we're going to write down the exact same steps. So good to kind of start putting them in our brain. So here we go. Mole-to-mole ratio examples. How many moles of oxygen are needed to react completely with 10 moles of hydrogen? So our first step up here says to write a balanced chemical equation. So we have hydrogen reacting with oxygen. And I know that we haven't predicted products, but maybe we can see our products from here. So I've got H2 plus O2. And that's going to give me, sorry, lots of color changes, but there's a reason for that. Anybody got a thought on what this might create? H2 plus O2? If you guessed water, you guessed correctly. It forms H2O. So that's the beginning of this, and now we're going to go back and balance it. All right. So eventually we're going to have a 2 right here. We're going to have a 1 in front of the O2, and we're going to have a 2 in front of the H2. And there is a reason that I did it in different colors, because hopefully you'll see that in just a second. So let's go through our question here and make sure we know what we're looking for. We're looking for moles of oxygen. So I'm going to circle that. We're looking for moles of oxygen. And we know we're starting with 10 moles of hydrogen. So we're going to use a T-chart, which we've been using since day 1 in here. So we've got 10 moles of hydrogen, and hydrogen is H2. So we're making our handy-dandy T-chart. Now, if we look back up here at the top, this is where we put where we're going over where we've been. So we're looking, in this case, for oxygen. So from our balanced equation, we're going to put 1 oxygen. All right? 1 mole of oxygen. That is where we are going. All right. On bottom, we're going to put where we've been, which is what we started with. In this case, it is 2 moles of hydrogen. This 2 came from this 2 right there, and obviously the 1 came from this 1 right here. And if we look at the chemical reaction and we read it officially, it says for every 2 moles of hydrogen, I need 1 mole of oxygen. Does that make sense? So if I have 10 moles of hydrogen, I need half that amount of oxygen because it's a 2-to-1 ratio. And so now we're ready to just do the calculation. Notice how our moles of hydrogen cancel. And we take 10 times 1 divided by 2, which gives us 5 moles of oxygen. All right, how does that feel? Does that feel all right? All right, let's try another one. Now, if we look at this next one, it says how many moles of water are formed from 2.5 moles of oxygen react. That's our same reaction. So we have that same reaction. So I'm going to copy it down just real quickly and keep my colors the same there. Sorry, my one looks a little rough, but hopefully we'll be all right. 2H2O. Okay, so now let's go back through and kind of look at what we got. All right, this time we're looking for moles of water. It says how many moles of water. So we're looking for moles of H2O. And we're starting with, in this case, 2.50 moles of oxygen. So again, on our T-chart, we're going to start with 2.50 moles of oxygen. We're going to put where we're going. What are we looking for? We're looking for water. So in this case, we're going to put 2 moles of H2O on top because that's where we're going. We're looking for water. So I put the 2 moles of H2O from my balanced chemical equation there. And on bottom, I'm going to put where I've been, which was oxygen, which is that weird looking one. All right, and we've got 1 mole of O2. And does that make sense to us? For every mole of oxygen I react, I form 2 moles of water. So I will make twice as much water as oxygen that I started with. So my answer here is 5 moles of water. And if we go back and do some canceling, our moles of O2 cancel. All right, awesome. Let's try one more with a different reaction, okay? This one's a little more aggressive. It says how hydrogen chloride reacts with barium hydroxide. How many moles of hydrogen chloride will it take to react completely with 0.947 moles of barium hydroxide? Whew, that looks aggressive, right? But luckily, Miss Griffith's just going to give this one to you. So we've got hydrogen chloride, which is HCl. All right. This is a double displacement reaction. So I'm going to go ahead and put everything in there. All right. Then we have reacting with barium hydroxide, which is BaOH2. All right. It's a double displacement, so our compounds switch partners. So Ba is now going to be chilling with Cl, and Ba is plus 2, Cl is minus 1. But again, you don't have to worry about this part. We didn't actually cover this part. And we're also going to form water. Now, we do have to go back and balance, and I wrote it in this manner on purpose, because if we look, 2 OHs and 1 OH, so I want 2 OHs there, but that now gives me 2 H's and 2 Cl's, so I need to fix that on the other side. So I have 2 HCl plus BaOH2 gives me BaCl2 and 2 HOH, or H2O, because remember, water can be either. All right, so we've written our balanced equation, and that was a little aggressive for us, but we'll be all right. So it says how many moles of hydrogen chloride, this is hydrogen chloride, react completely with 0.947 moles of barium hydroxide. So we're going to start with 0.947 moles of barium hydroxide. Put that on our T-chart. And here's where we go to our balanced chemical equation, right? Balanced chemical equation, we're going to put where we're going on top. We're going to HCl. That's our question mark. So I'm going to put 2 moles of HCl on top. That's from my balanced chemical equation. On bottom, I'm going to put 1 mole of barium hydroxide. That way, the moles of barium hydroxide cancel. Boop, boop. All right, and we're ready to do our calculation. So we're going to take 0.947 and multiply that by 2. And we could divide it by 1 as well, but we're just going to take it times 2 because let's be real. And so we're going to get 1.894. And our label is moles of HCl. And that is all we have today. All right, I'll see you next time.